Okay, let's look at the checkup for 3-2. This is what you are supposed to be doing before you come back to school. It says identify the slope and y-intercept of y equals 3x minus 4. Remember, slope-intercept form is y equals mx plus b. So they give you the equation y is equal to 3x minus 4. So 3 is your slope and negative 4 is your y-intercept. The slope is 3. The y-intercept is negative 4. Okay, next question. Margaret has $50 to spend on supplies for her hiking group's trip. Granola bars are $1 each, and bottles of water are $2 each. Margaret can model her possible purchases with the equation y is equal to negative 1/2 x plus 25. It says this function is either linear or not linear. Well, does the price of granola bars ever change, or is it always $1 each? Same for the bottles of water. They're always $2 each. So this is linear because it is increasing or decreasing, whichever way, at a constant rate. Select the table that represents a linear function, graph them if necessary. So with this, what you want to do is look to see if there's a constant change in the x's and a constant change in the y's. If there is, then it is linear. So the x's go up 1, 2, 3, 4. That's constant, same every time they go up by 1. The y's from 3 to 4, that goes up 1. From 4 to 6, that goes up 2. From 6 to 9, that goes up 3. So no, that's not a constant change. This is not linear. It's a function, but it's not linear function. It's not a line if you were to graph it. B, 1, 2, 3, 4, yes, that's consistent. 5, 7, 9, 11, yes, that's going up 2. So that is a linear function. It would make a line. 1, 2, 3, 4 on C is good. It goes from 10 to 9 to 8 to 7. It's going down, but it's constant. It's consistent. It's going down 1 each time. This is going up 1 each time. So yes, that is linear. D, all the x's are the same, but this is going up 1 and then it's staying the same and then going up 1. So no, that's not linear. E, the x's are good. This is going from negative 1 to 1, which is up 2. 1 to 3, that's 2, but then it goes back down. So the change is not constant. So only B and C are linear functions. Okay, it says Sunil steadily descends on a zip line from one platform to another. After 8 seconds, he's 110 feet above the ground. After 12 seconds, he's 94 feet above the ground. That's given us 2 ordered pairs that we just read right there. The equation of Sunil's height over time is linear. He's dropping at a constant speed. What does the y-intercept represent in this function? Remember, the y-intercept always tells you where things start. It says he's going from one platform to another. So it would be the height of the first platform. What does the slope represent in this function? Well, the slope is the rate of change. It's the rate at which his height decreases. The slope could be found by dividing the difference between the heights, that's your dependent variable, those are your y's, by the difference, I can't go down here, the difference between the 2 corresponding times. Okay, and I have about a minute. I don't know, I may have to make 2 parts to this. Okay, it says Sunil's height at a time of 0 seconds was, it tells us right here. Sunil steadily depends on a zip line from one platform at a height of 142 feet. That's where he started. So his height at 0 seconds, where he started, the y-intercept is 142 feet. The y-intercept of this function is, if it started at 142 on the y-axis, this is the point that's on the y-axis. The other point they showed, this one right here, that's on the x-axis. What is a correct calculation for finding the slope? So let's look at our 2 ordered pairs. Well, they're in the table too, and I'm going to have to do this on the next video because I'm about to run out of time. Let's see what I can write right here. 8, 110, and 1294. Got my own timer here, but it also tells me a timer on the Screencastify, but I'm going to go ahead and stop this and make another video for part 2.